Tonight we're picking up where we left off last week, and we're on slide 52 in the chapter 4 PowerPoint, and we're going to be looking at this important structure. It's basically a different way to do decision statements in programming. Most programming languages have this type of a structure, and the structure that we're going to be looking at is basically what some languages will call switch statements or select statements or case statements, and they'll all have similar syntax in all the different languages you look at. And where this becomes particularly useful is if you find yourself writing an if-else statement or a series of them, and you're checking, multiple conditions. So for example, if I was maybe writing an application where I was checking to see which state the person lives in, and I would have like a else if equals Wisconsin, else if equals Illinois, and I have to do that 50 times, maybe throw in a couple territories like Puerto Rico or something on top of it. You're writing all those statements over and over again. It gets very repetitive and really kind of inefficient from a coding standpoint. So they came up with this approach where you set up a case statement, and what you do is you come up with basically what they call a value list, or a list of different possible inputs that would trigger certain pieces of code. So we don't use the keyword if, we'll use case. So we'll check to see what the situation is for a certain variable typically, or value coming in. Based upon that, very often, they're giving you a little example application here. Depending on what position they're working with, that will drive the code. So take a look at the next slide here. And this is a typical layout for a statement like this. So notice they've set up some sort of an integer here as a variable called position. They're doing a conversion on it right off the bat. So as they're declaring the integer, and this is kind of a different approach, and something you might actually consider doing in your applications, notice that they're assigning a value to the variable right off the bat, and they're doing that conversion to an integer straight from the text box off the screen, right as it's being declared. Now, for some young programmers, that can be kind of a lot to absorb all at once. So if that confuses you in any way, what I would suggest is make the statement separate. If you want to declare the variable separately, do that and then give it a value. But if it's possible for you to grab it from the text box, convert it to an integer, and put it right into the integer as it's being declared, because it's only going to be triggered from that button press, for example, it's actually a fine approach to use, and it saves on the lines of code as well. All right, but looking beyond that to our actual topic, notice the setup here. We have basically the keyword select and case, and notice the end select at the bottom. And then what we do is we basically take whatever that variable is that we're feeding in, and we're looking at whatever is in it. And we're saying here, in the case that it is the number 1, these are the statements that we're going to execute. And you can see how this can save on a lot of coding. So instead of having else if position equals 1, we just say case 1. It's a lot less to type out. And once again, I find this structure useful if I find myself maybe doing maybe a few more than a few else ifs, maybe like 3, 4, or 5 of them, and then I'll switch to a case statement instead. It's a little bit more efficient. Notice also the capability here in a case statement to actually do compound selections. So in other words, if it's 4, or 5 is really what it's saying, you can do this statement. There also is what we call kind of like a little catch-all statement, kind of like a regular else, that will execute if none of the conditions hit. Now that is not required that you have that in there, but that is, sometimes necessary depending on the logic of the problem that you're solving. So basically the situation that they have here is a little application where you're going to type in what position you finished in, and then depending on that, it'll say gold, silver, bronze, or you almost won a medal if you're in 4th or 5th place. Everybody else apparently doesn't matter too much, just like the Olympics. And they're an example of the output from that little simple application. Let's take a look at another one. And with this one, same type of setup now. And notice the first case statement actually says case 1 to 3. And what that is doing is it's actually declaring a range of integers. And then you can also put in logical operators too in these statements. And notice we have the keyword is, and we're looking to see if the case of position is greater than or equal to 4, and then we have a different output based on that. Notice this one does not have the else in it. That is not required. So that kind of gives you a good overview of how that structure works. In terms of the general syntax of it, this is what it looks like. And one thing I do want to mention here, if I was doing the same type of thing in a language such as Java or C#, for example, whenever we would do a case statement in those languages, every time we get into the action portion of it, in other words, the statements that are inside each case statement, at the end of each one, we also have to put in what we call a break to stop it from executing further. Visual Basic is an oddball language, and I always feel like I have to point that out whenever I teach this language, is in other languages, you have to add break statements in. Visual Basic actually allows you to not include that. But what's happening is that is happening in the background. So when you get to like learn Java or C# or whatever other languages you're learning, and you learn this structure, very often you'll see that included. There are a few different things in terms of rules that the author is pointing out. You know, what types of things can be put in there. A literal, do you guys remember what a literal is? It can, yeah, it can be text, but it also can be numbers. And basically what that means is instead of pulling in a variable and checking in a variable for its value, we're actually literally passing in a number. So if it was a string, a piece of text inside of quotes, or if it's a number, we're just hard coding the number right in. But that's what a literal is. Whenever you hear that, it's literally the value. It's not something that's placed in a variable or not something that's being calculated. It literally is the value that you see. You can also send in a variable. You can do an entire expression, so you could have a mathematical expression in one of the case statements to see how it evaluates. And sometimes that's a real practical approach to make decisions. Notice that they have a thing here where we saw in the previous example where they use the keyword is. So if you are working with any sort of logical operators in that capacity, you have to proceed with that keyword is in order to make it work. And if you don't do that, it will remind you very quickly with the debugger. All right. For those of you that are going to be pseudo-coding solutions, how does a case statement work in terms of flowcharting? We still use the decision diamond shape to do the flowcharting, except we would break out to the side with our actions. We're still working top-down in essence, but we're just kind of going through the decisions in a little bit different fashion. When we were doing if statements, and especially when you start to do nested if statements or a bunch of else ifs, those drawings can look pretty bizarre actually, because you can start to branch off to the side a few layers deep. And we're going to actually work on a couple of pseudocode solutions in this unit where we will be doing that, and I'll show you exactly how that works. Is it important to pseudocode these things? When you're working with a real complex application, you know, and I always have to kind of refresh this in everybody's mind, the stuff that we're building right now is pretty simple. And it will get more complicated as we go along. But when you're building a real application that's got a lot of different components to it, and it gets really complicated, there's almost no way that you can kind of skip the pseudocoding process. Whatever you happen to use, you know. And Patrick, you work as a professional programmer. How often do you guys pseudocode stuff before you actually dig in and code things? Yeah, it gets messy. It comes back to bite you is what happens. And if you pseudocode well, if you have a good strategy for doing it, very often, I mean, it can be such an excellent roadmap to building the application to make sure you're not forgetting things. But this is what that structure would look like. I don't know how all design firms work, but typically they'll have some method, whether it's just writing it out by hand, maybe on a whiteboard or a piece of paper, whatever the process is. Some people get very formal with it, where they get it into Visio or they put it into various programs to do it. But that's really dependent on the projects and the complexity. All right, I think that's enough on that section. So I'm kind of moving on to the next section here. So I'm down on slide 67. All right, and they're giving us a little bit of an example here, and I'm not really sure what the point of this slide is, honestly. It says items in the value list must evaluate to a literal of the same type of data as the selector. So in other words, if you are telling it to select first name as a string, and then we try to run a case statement where we're looking at the length of it, what would this generate? It would generate a number, right, if it's looking at the length of a string? And that's not allowable, is what they're telling you. This would generate a number, but we're selecting against a string, so that case statement is not helpful. Talk a little bit about scope also. Do you guys remember what the scope of a variable is? How would you describe that? That's not a bad way to look at it, sphere of influence. But it's basically where it's valid within the code. So if we were to, let's say, double click on a button in our application and we create a little code stub and we're typing in our code and we create a variable inside that little subroutine, that variable only works inside that block of code. And that's really what it refers to. Now notice it says a variable declared inside an if or select has block scope, meaning you can't use it outside of that statement. So it is possible to actually create variables inside these statements. You just can't use them anywhere else but inside those statements. I know that from a beginning programmer's standpoint, it's like, why on earth would you ever bother to do that? There are circumstances where that is a very appropriate approach. Just very simply because you don't need to create a variable unless a particular case it happens, right? So why actually create a variable that you're not even going to use? You only create it if that situation is applicable. The benefit of that is that you create an application that's more efficient. It's not utilizing resources in memory or processing power, only if it's necessary. And that's the kind of thing that you think about, especially when you gain experience doing this, that comes into play a lot more. And I don't care how much processing and RAM capabilities we have in our machines, it's always important to write efficient applications. It makes for a better user experience. It's overall a positive for sure. All right. One thing that's going to be new to us here is we're going to learn a few new controls that we're going to be throwing into our Forms applications. And some of these you've probably seen in other applications. And if you've done any HTML work, these things look pretty common too. The round little circles, we call these radio buttons. Little square boxes, we call check boxes. And we're going to create some of those in our application where we're going to be able to detect whether a box is checked or not, and then take action based upon that. So it's a different form of input. So instead of somebody typing in a value, let's say like a number or a string, in this case we're just checking to see which one of the things they picked, right? And in some ways this is a really great way to control problems within an application, because if I wrote, let's say, an application where I said, okay, what year are you in school? I might get somebody that would type in, I'm in my second year. But you're expecting them to type sophomore. And then you're also expecting them to type it correctly. So by giving them radio buttons, you kind of control that, because you're controlling what data is being sent. It can't be mistyped. The other thing is they can't enter in data that's not possible. And depending on the logic that you're using, notice that with radio buttons, they have this unique feature that when they're part of, see that little gray box that goes around them, when they're part of that gray box, I can only select one of them at a time. So you can't be a sophomore and a junior at the same time. You can be a senior and a super senior at the same time, I think, right? Bad joke, I know. The checkboxes have a different type of quality to them in that you can make a selection like you can with a radio button, but you're allowed to select multiples. So you can actually feed in multiple pieces of data. If I wanted, I could click all those boxes. I could because I've learned all those languages. And hopefully someday you guys will have learned all those as well. Another option, of course, on the far left there is a list box. And the list box, now we've used list boxes to do output, where we were able to take what we were generating from the program as results and then just add a line of text to the list box, kind of like working in a console application. But in this case, we would pre-populate a list box and allow a user to actually click on a line of text inside there to actually use that as an input for the program. So these are basically three different ways that we can start adding these things to our applications. Right, just a real quick little graphical overview. In the subsequent slides here, the author goes through a demonstration of how to use these. He starts with the list box. And the list box is really kind of one of these first objects that we put on the screen where we're going to start actually using that tasks button a little bit more than we have in the past. And for the most part, you guys probably haven't even touched that. But this is a little button that you see on many of the controls, and when you see it, you can click it, and when it opens up a separate dialog that allows us to create and control certain features of that object. In some cases, for example, a list box, when you're writing something more complex, allows us to actually interface with the database. We can actually put in database connection strings, and that would lead directly to a database table to pull in, a certain list of things, and it'll do it dynamically. And that's one of the neat things here. And actually, I'm thinking more of a data grid view, honestly. But it's the same type of concept. Here, notice that you're going to have an edit items list, and what is going to happen is you'll click that, and you'll go to another screen, and you'll see that you can actually type in all the stuff that you want to appear in the list box. And once it's typed into the list box, then the user has that capability of clicking on one and selecting that string, and then using that to drive the input for the program. They're showing on the next slide what it looks like, what you're saying, at runtime. And just an example of a type of thing that you might do is you might create a list of all the months of the year, and then you might write a thing that if you click, see the terminology here, making a decision, if you click on October, it looks up in the table how many days are there in October, and then it'll do the output and drop the text of 31 into the little text box there. All right, I'm going to kind of fast forward. I'm not too worried about the code here at this point, more the concepts than anything else. There's another thing that we'll learn how to use, and that is the ability to group certain controls together. Now that becomes pretty important, especially when we move to the radio buttons. And the radio buttons, we're going to be checking with them to see if something is, enabled or not. Now notice also that they're using a different prefix for the controls. So for buttons, we were doing like BTN, and text, we were doing TXT. And here the convention that they're pushing is that for a radio button, that when you name the object, that you use RAD in lowercase. And remember, you can use whatever makes sense to you. People that are comfortable with languages like Java and GUI programming in Java often will use RDO for radio. Remember, conventions, not rules. So you don't have to name your objects that, but if it helps you to find it on the form or the code, I think it makes a whole lot of sense that if you name it well, it works well for you. All right. Yes. Yeah, it's pretty rad. Good joke. All right, but notice how the age box is grouped around those 4 radio buttons, and that is that with that being placed there, that forces those radio buttons to kind of act as one unit, forcing you logically to not be able to be a child and a senior at the same time. And the logic of your program is what's going to dictate what structure you use. Remember that. All right. Skipping past the code once again. And let's go down to checkboxes. Checkboxes, with these, you don't necessarily need to group them. Notice the naming convention prefix there. They use a CHK for it. For both radio buttons and for checkboxes, the one thing that we will typically look for in our code is to see very simply if something is just checked. And if it's checked, we'll do a certain action. Now, if you're working with radio buttons, that really kind of dictates a different type of logic. And notice that here with checkboxes, we're just using if statements, right? Because it's possible to actually select multiples. So I can have the first one checked, the drugs one checked, the dental checked, and the vision and the medical, because I want all those, right, for my health insurance, for example. If you scroll back up in the slides and you look at the radio button and the logic behind those, notice that these are else ifs, because it's not going to be possible for you to check all of them. So it's going to fall into a certain condition. So else if would be a good thing here, or a select case statement would be a good thing to use here as well. Once again, you're just checking to see if that button is checked, and if it's checked, then you perform a particular action. All right. All right, that covers all the stuff I want to talk about in this chapter. At this point, we're going to switch over to doing some work. So that concludes the Chapter 4 lecture materials. Nice and abbreviated, didn't take as long as last time. And I will see you guys in the next video.